Hello everyone, welcome to Learning Physics with David Awakim. Today we'll be talking about the metric system. So if you don't already know, the metric system is what we use in science to measure things. And in physics, you're going to measure a lot of things. Trust me, you'll get used to it, it'll be fun. Some of the basic units that we use in physics are things like meters, grams, liters. These all measure specific things, and these units of measurement can be categorized into one of two types. Here we have fundamental units. This is a picture straight out of your textbook. These are units which just exist. They are facts of nature. They are here, and yeah, we just gave them names. A meter is the basic unit for distance, kilogram for weight, how much stuff is there, seconds for time, amperes is for current, which we will use to build onto electricity in the future of this course, later on this year actually. Kelvin is the basic unit for temperature, how much energy is in something. Moles is like the counting unit. You should have worked a lot with it last year in chemistry. This essentially counts how many of an entity there are. And lastly, we have candelas, which are the units for luminescence, in other words, how bright something is. In the meantime, we also have derived units. These are units which they don't exist in nature by themselves, but they exist from an interaction of two or more of these earlier units. For example, we have velocity, which is nothing but meters per second. Or there's the unit of force, newtons, which is nothing but kilograms times meters per second squared. And this definition, while it seems a bit iffy for now, it's going to make sense a lot later in this course. And so yeah, every metric unit is either fundamental, one of these seven, or it's derived from an interaction in between one of these seven units or more. And by that I just mean, for example, in newtons we have kilograms, meters, and seconds all interacting with each other. There's only seven fundamental units. And for any and all of these units, which can be measured as a one, here's just a quantity of something having one of said unit. In the metric system, we usually work with very big numbers or very small numbers. And instead of writing a bunch of zeros over and over and over again, we can just add these prefixes. We add them to the back of the unit because they're a prefix to tell us know how big or small a unit is. For example, tera, which has the letter T as its abbreviation. So for example, 1 terameter is nothing but Tm. That means 1 trillion of something. So this is 1 trillion meters, a very, very big distance. Moving on, we have giga, G, mega, M, this is a million, kilo, K, hecto, H, deca, D, A. We use dA for deca because over here on the smaller end of the scale, with units getting smaller and smaller, we have a regular D for deci, a C for centi, M for milli. Micro is where it gets interesting. We have the Greek letter mu. It looks like a 4, but it's a Greek letter, mu. We use it because that's the way it is. It was convenient back then with the ancient Greeks, and the usage just carried over until now. Nano and pico is a P. And as you can see, each of these prefixes just means that a number is much larger, and which are denoted with capital letters. For example, a megagram is a million grams, grams being the base unit. And over here on this side, we have the smaller prefixes. For example, a nanometer, it's a very, very small distance, most incredibly small. Um, yeah, these are metric prefixes. You don't really need to memorize all of these. The ones that you use most often are kilo, centi, and milli. These are the ones that you should really get used to using. But don't worry, your calculator should have a way to convert in between these units, and you can always just look them up as you need them. I hope this has been helpful, and I'm looking forward to future lessons. Goodbye, everyone.